All right, let's just jump right in. We all know computers are ridiculously fast, right? They can do these incredible calculations in like the blink of an eye. But here's the thing, they're also incredibly literal. They're super powerful, sure, but they have absolutely zero common sense. So to get them to do anything at all, we have to give them a perfect, logical set of instructions. And when I say perfect, I really, really mean perfect. I mean, look at this recipe. If you handed this to a computer or, a very trusting person, the results would be, well, explosive. Every single sentence is grammatically correct, but the logic, it's a complete and utter disaster. The order's all wrong, one ingredient is just catastrophic, and a key step is missing until the very, very end. And this just perfectly shows you the core challenge of programming. A computer would absolutely 100% try to add a gallon of gasoline to your cake batter just because you told it to. It has no way of telling the difference between a good idea and a terrible one. Its only job is to follow the logic you give it flawlessly. Our job, as programmers, is to make sure that logic itself is flawless to begin with. So yeah, thinking about our gasoline cake, it perfectly illustrates the two main types of errors you can make. See, a syntax error is like a typo, spelling flour wrong. The computer spots that easily. But a logical error, like adding gasoline, that's way more dangerous. The instruction itself is written perfectly, but the idea behind it is just fundamentally broken. And that is what programmers spend their entire careers trying to avoid. So that's the big question, isn't it? If a machine is this rigid, this literal, how in the world do we build something as complicated as a video game or a social media app without it just constantly falling apart? Well, the answer, it turns out, is surprisingly simple and kind of elegant, actually. It all comes down to just three basic rules. Yep, that's right. Every single piece of software you have ever used, from the simplest calculator on your phone to the most complex operating system, is built from just three fundamental structures. You can think of them as the primary colors of programming logic. Let's break them down. First up, we have sequence. This is the most basic rule of all. It's really just a to-do list. You do step 1, then you do step 2, then you do step 3. In a proper cake recipe, you mix the dry ingredients before you add the wet ones, right? The order matters, and sequence just makes sure things happen in exactly the right order. Next up, we've got selection. Now, this is where programs start to get smart. Selection is basically just a fork in the road. It asks a simple yes or no question. So for our cake, if the toothpick comes out clean, then take the cake out of the oven. Otherwise, you bake it for another 5 minutes. This is what allows a program to react differently to different situations. And finally, there's the loop. This is the real workhorse of programming. A loop just repeats an action over and over and over again until some condition is met. For example, while the batter is still lumpy, keep stirring. A loop saves us from having to write stir 1,000 times. It just keeps on going until the job is done. Okay, so here's the most crucial point. These three structures, sequence, selection, and loop, are the only building blocks you need. That's it. Seriously. Every complex program you can imagine is just these simple patterns nested and combined in really clever ways. It's kind of like having only 3 types of Lego bricks, but being able to build an entire city. Now, while each of these rules is pretty simple on its own, it's the combination of selection and loops that really gives software its power. Decisions let a program handle all sorts of unique situations, and repetition lets it handle massive amounts of data without even breaking a sweat. What's really interesting is just how simple a decision is at its core. It always boils down to a simple choice, true or false, yes or no. This incredibly simple structure is what allows your phone to decide if your fingerprint is valid, or a website to decide if your password is correct. It's that simple. So we have these powerful building blocks. But what happens if you just, throw them together randomly without any kind of plan? Well, you get the programming version of our gasoline cake. You get total chaos. In the programming world, this chaos actually has a name: spaghetti code. It's a program where the logic is so tangled and crisscrossed that trying to follow a single instruction is like trying to trace one single noodle in a giant bowl of spaghetti. It's a mess. And it's the exact opposite of how professionals work. And the difference is, well, it's night and day. Structured code, which uses R3 rules cleanly, is like a well-organized blueprint. It's easy to read, it's easy to fix, and it's easy to add new features. Spaghetti code, on the other hand, is a tangled knot that's a total nightmare to debug or update. Honestly, a lot of the time, it's just easier to throw it all away and start over. And this is exactly why structured programming isn't just a good idea. It is the only way professional software gets built. It's efficient, it makes maintaining code possible, and it allows huge programs to be built by entire teams of developers, where each person can work on a separate, well-defined piece of the puzzle. So we have these 3 simple rules, but how do they connect to the crazy, complex digital world that we use every single day? This is where it gets really mind-blowing. So on the left, you see a program running in a simple text terminal. And on the right, you've got the exact same program, but it's running in a modern graphical window with buttons and text boxes. They look completely different, right? But, and this is the amazing part, underneath the surface, the core logic, that sequence, selection, and loops doing the actual work, is exactly the same. The what it's doing is identical, only the how it's presented to you has changed. And this is the most important thing to take away from all of this. From the app that wakes you up in the morning, to the web browser you're using for work, to the most complex 3D game you play at night, every single one of them is just a massive, intricate structure built from those same 3 simple, elegant patterns. So I'll leave you with this thought. We have this vast, interconnected digital world that feels infinitely complex, right? But at its very foundation, it's all just built on a handful of simple, logical rules. If we can build entire universes from such a simple starting point, what other complex systems in our lives might be governed by equally simple principles, if only we just knew how to look for them?